I got almost 10 minutes. All right. So again, as we decrease this pressure, now think of it this way: the pressure inside the bell jar was holding that balloon constant. Well, if you remove the pressure, there's nothing holding the balloon, so it's going to expand. So those two pressures are working together, and once this one drops to 0, this one wins. All right. So that's another way to say it. The pressure in the balloon is trying to get out, or is holding the balloon to a certain size. The pressure outside is keeping it at that size, so they're like a stalemate. Once this one decreases to 0, this one wins, so the balloon's going to start to expand. This law is actually called Boyle's law. It's a pressure-volume relationship, and I'm going to get to that not right this second. But so that's the real explanation. So when the pressure decreases, that balloon is no longer held in check, so it will expand. Questions? So these same 10 particles now, there's a little balloon here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They just spread out. It's the same number of particles, same balloon, it's just expanding because I decreased the pressure. Think of that's fun. High pressure takes up a little space. Release the pressure, takes up a lot of space. Question? Comment? We're going to get to that later this week. Yeah.
Why do you write just like random crap all over your board and then just like don't erase it? Like you had entropy up there for like 5 years.
To make sure I give you notes on it.
We already have notes on it.
No, that was for a review question, which I just did. I use everything I write. You just may not know it.
You have the sea ice thing.
Yeah.
Yes, I need to do it. I still need to do it.
Why do you have Renee in like a circle?
Oh, don't worry about it. You guys are worried about things you don't need to be worried about. All right, now, back to our notes here. So, let's talk about air pressure in mountains. Okay. Draw the land. Draw a big mountain. All right. Who wants to be down here on the ground?
No,
Yes, Stavros would.
Stavros?
Wait, we're drawing this?
As volunteer quick.
There's Stavros. Okay. Who's on top? Someone's got to be mountain climber.
Well, like me.
Who? Lexi?
Yeah.
Okay.
There you go.
No.
Okay.
And then you have one of these, what is
Really
it, pickaxe
yeah.
thing here? I don't know what that looks like. That looks like a nail. All right, so we'll give you faces too.
Yeah.
Stavros is smiling. Lexi's not. All right, so now I'm going to draw with dots what the air looks like. So if you understood the demo and what I just drew, I want to represent dots as air. So there's going to be some dots down here, and there's going to be some dots up here. So let's say this is a really, really high mountain. It's Mount Everest, let's say. So Lexi's all the way on the top of Mount Everest, and Stavros is way down.
I'm just watching you.
Yeah, sort of. You can see
He
her,
was
but
too scared.
now, she wouldn't be able to breathe. Why?
There's no
Air's too thin.
Air's too thin, not as much oxygen. She would need an oxygen tank, all right? He could breathe fine down here. So I want to, let's think oxygen. I want to put dots around that. How am I gonna draw these dots? Well,
They have more of it at the bottom than this.
more at the bottom, yeah. 1, 2, 3, 4. You know what? You don't have to count. But just put a whole bunch of dots around Stavros. Stavros being attacked by oxygen. Now, up here, okay, the dots are very spread out. So at sea level, air, oxygen, is actually fairly concentrated. So it's easy for us to breathe in this room because there's a lot of oxygen right in front of our face. Take a deep breath, you're getting a lot of oxygen. You go on top of Mount Everest with Lexi, she takes a deep breath, she's not getting any oxygen.
Yeah, I'm gonna die.
Yeah, so she needs an oxygen tank. I don't really know how to draw that, so whatever. So here, we can,
Have a backpack.
here's an oxygen tank. So that just looks like a mess of lines. So anyways, the concept I'm trying to teach here, there's a couple things going on. Low altitudes, close to sea level, high air pressure. You said the air is thin, right? So up here the air is thin. I'll write that. Air is thin. and that creates low air pressure. What causes air pressure again? Oh, air particles colliding. If you just look at this picture, imagine the dots are bouncy balls trapped in this room. If you have, I don't know, 100 bouncy balls between all of us, how many of us are there? Let's say each one of us is holding 20 bouncy balls. We just spike them into the ground at the same time. There's going to be a lot of collisions. If each one of us holds one bouncy ball and spikes it in the ground, they may never collide with each other at all, actually. So the point I'm trying to make is if there's more particles, more air, more oxygen, they're going to hit each other, collide more often, creating more pressure. So that's 1 ATM, let's say. Up here, because the air is thin and spread out, it has expanded like that balloon. As altitude increases, air expands. There's much bigger spaces, so the particles don't collide as often, therefore creating lower pressure. So if down here we're at 1 ATM or 101.3 kPa, these are two numbers you need to know, both on the reference table. Up here, maybe it's like 0.3 ATM, or I'm trying to convert that off the top of my head here, but you know, a third of that number, so 30 kPa, right? So 30, we'll say 33 kPa. So that's not perfect, but you understand what I'm saying. So the pressure decreases, there's less collisions, therefore you can't breathe. There's not as much air. So really what happens is the air thins out, but why? Go ahead.
Gravity.
There's a little bit more to it.
Heat. Energy.
Naming random things up.
Random signs.
Well,
Yeah.
there's less air.
Density, volume, speed,
No, 'cause heat and
Altitude.
gravity
altitude.
Pressure?
It's the amount of space up on top of the
Lights, please. Ugh.
Smells like a campfire from that. Or with the oxygen thing.
You don't have to do that. This is just me quick. Go ahead, Sam. I know. All right. So there are layers to the atmosphere. You have your troposphere, which is where we live, stratosphere, mesosphere, mesosphere, thermosphere, and then you keep going up to space. So these layers explain why at sea level there's a higher pressure, and the closer you get to space, there's less pressure. I'll give you another example. Let's say all of us stacked on top of each other one-on-one.
Like vertically or horizontally?
So laying on our stomachs. Who's going to be at the bottom?
Yeah.
Luke's at the bottom. Everybody lays on top of Luke, and then everyone we stack like firewood. Person on the top feels no pressure. What about Luke? Poor Luke.
He's
He's gonna be a
dead.
pancake. Yeah, he's gonna be a pancake. All right, he's gonna be dead. So the point of it is the air and atmosphere works the same way. So there's higher pressure down here, and even the lower you go, experience even higher pressure. And then as you get closer, so really tall mountains get to the top of this area, there's all that air below it. So that's ultimately why air expands or thins. When you get up to here, real close to space, the air is ridiculously thin. So that's actually something cool you may not have known or thought of before, but that's essentially what causes the particles to be closer together and more concentrated. And again, this deals with gas laws, which we will get into here very soon. Pressure is a big part of that. So I spent time talking about it because you need to really understand what pressure is. Volume and temperature are the other two factors. They're easier, I feel like. So, all right, obviously I'm out of time. Tomorrow, you're going to take that quiz, and then I'll have a worksheet pertaining to gases, pressure, temperature, and volume. You might have to do some stuff in the books, too.